Hope you might have a good health. I am Arya of class 10. In 2020, October 18 till October 24 is celebrating as a National Chemistry Week. We are all chemists. Even our bodies are made up of chemicals. When we eat or when we just sit down, the chemical reactions are taking place. So, chemistry is the study of everything. But how does the chemistry occurs in everyday life? Yes, the most obvious place is in the kitchen. Have you ever noticed the gas burners in kitchen? Yes, they usually burns with a blue flame. But when the gas burners get older, they start burn with a yellow flame. Not only that, it also gives out a thick black soot which spoils the bottom of the vessel. Now you can see the pictures of blue flame, yellow flame and a black coating under the bottom of the vessel. Have you ever wondered why this happens? Yes, it has a chemistry behind it. The only answer for this is the complete and incomplete combustion process. Then what is the reason for getting a yellow flame? When the gas burners get older, the air holes get clogged and as a result, all the oxygen needed to burn the fuel which will not reach it. That is the reason why we are getting a yellow flame. And it is clearly indicates the inefficient use of fuel. Now, I hope that you have understood the chemistry behind it. Thank you.
Have you ever faced a situation like this? I hope you have faced. I had also faced such a situation before. During this situation, I have taken the Gelusil syrup to overcome from this situation. Is there any connection between this and chemistry? Do you know? Let's see. The reason why we suffer the pain and irritation is that our stomach produces the hydrochloric acid. The dilute hydrochloric acid helps in digesting our food without harming the stomach. Sometimes excess of acid is produced due to various reasons. The excess acid in stomach causes indigestion which produces pain and irritation. By taking bases called antacids, we can avoid the pain and irritation. Gelusil is an example for antacid. Antacids are a group of mild bases which have no toxic effects on the body. Being basic in nature, antacids react with excess acid in the stomach and neutralize it.
Amazing, right? Come on, let's see what happens here. Hi friends, good morning. I'm Vaishnavi of class 10 from Vasavi Vidyalaya Kinasseri. Here, I'm going to tell what happened to my handkerchief when I put soap solution into it. See? It changed into red color. But how? I will explain you through an experiment. Before that, just a reminder about acids and bases. We all know what is acid and base, but how to test whether a substance is acidic or basic? We will just taste it, right? But it is not possible for us to taste each and everything and to identify the substance is acidic or basic. For that, we use indicators. Then the question arises, what is indicators? Indicator is a substance which changes its color when it put on acidic or basic medium. There are two types of indicators. One is natural indicator and the other one is artificial indicator. Turmeric is an example for natural indicators whereas phenolphthalein or methyl orange is example for artificial indicator. Here I have taken turmeric solution for my experiment. This is soap solution and this is lime juice. So I'm going to take 2-3 drops of turmeric solution and I'm going to put it on soap solution. Just mix it well. See, it changed into red in color. Same was I'm taking the same quantity of turmeric solution and I'm going to put it on lime juice. There is no change. It is still yellow in color. From this, what will we understand? Turmeric will change its color when it put on basic solution. So we can conclude that soap solution is basic in nature, whereas lime juice is acidic in nature. Because of that, it doesn't change but still remains that yellow in color. And that's what happened in my handkerchief. So I hope you all understood this and thank you.
Hello everyone, I am Dia of class 10. In our daily life, we would have come across several chemical reactions which we would never realize, but it happens. Today, me and my friend Swati are going to explain you such a reaction that happens in our kitchen.
Procedures for the formation of curd. Take 1 cup of warm milk, a teaspoon of lemon juice. We use lemon juice because the lemon juice contains citric acid. Add the lemon juice on the milk. Stir well. After some time, we can see the formation of curd. Curdling of milk. As you know, milk is slightly acidic in nature. When the pH is lowered even more by the addition of another acidic ingredient, the protein molecules stop repelling each other. This allows them to stick together or coagulate into the clumps known as curd. This process is called curdling of milk. Curdling occurs naturally in cow's milk if it is left open to air for a few days in a warm environment. Procedure for baking cake. Ingredients needed are sugar, eggs, flour, salt, vanilla extract, powdered sugar, cocoa powder, butter and baking powder. Baking powder is used to increase the volume and lighten the structure of baked goods. It works by releasing carbon dioxide gas into a batter or a dough through an acid-base reaction, causing bubbles in the mixture to expand and thus leaving the mixture.
An important constituent of our daily food are carbohydrates, which we consume in the form of starch. Starch gets converted into sugar during digestion. Iodine solution can be used to test the presence of starch. Iodine is yellow-brown in color. Starch reacts with iodine to form a blue-black compound. So, the food items containing starch will turn to blue-black when iodine is added to it. Now, let's conduct an experiment to test the presence of starch in some of our daily food items.
Hello everyone, I am Ashwin Arnaya of class 10B. Today I will be doing an experiment that helps us to understand the properties of natural indicators like turmeric. What happens to turmeric when base or acid is added to it? Does it show change of color or show change of state? These are all examples of chemistry in our daily life. To know more about this, let us go into the video.
Good morning, I am Revati from Vasavi Vidyalaya and I am studying in class 10th B. I am here to explain rancidity. Rancidity, the oxidation and fats present in the food material to form the products that have bad smell and taste is called rancidity. And how we can prevent rancidity. And I will show you one example of one food item. This is one food item. After 2 days, we can see the changes of this food item. Now see the changes of this food item. So to prevent this, we stored this food in a tightly packed container or in a refrigerator or by storing food away from lights. Thank you.
I'm Shravana. We are aware of the fact that cutting onions will make us cry. Today I am going to explain the science behind how onions are able to do it.
Why do onions make us cry? Onion consists of amino acid sulfoxides. When we cut an onion, millions of onion cells rupture, releasing the amino acid sulfoxides along with some special enzymes. These special enzymes react with amino acid sulfoxides to form a chemical called syn-propanethiol S oxide. This chemical is volatile, that is, it easily evaporates at normal temperature, forming a gas. When this gas reaches our eye, it reacts with the substance that keeps our eyes lubricated and forms mild sulfuric acid. This sulfuric acid gives us a burning sensation. Now, in order to wash off this acid, our lacrimal glands produce a disinfecting liquid, but when our eyes cannot hold any extra amount of disinfecting liquid, it starts to fall down, making us cry.
Hi everyone, I am Prisha of class 10 here to discuss rust remedies. What is rust? Rust is a reddish brown substance formed by the reaction of iron and oxygen in the presence of water, air or moisture. There are many easy methods to remove rust. Here let's see how to remove rust with the things that are easily available. I have taken a cutting blade which is rusted. The things we need are a potato, baking soda, that is sodium bicarbonate NaHCO3. Also, we can replace the baking soda with lemon water or common salt. First, let's cut a potato and sprinkle some baking soda over the potato and then rub the potato on the rust spot. The oxalic acid present in the potato helps to dissolve the rust. At last, we can see the rust particles stick over the potato. I hope it was helpful to all. Thank you.
Have you ever tasted or smelled the fat oil containing food materials for a long time? When fat and oil are oxidized, they become rancid and get the smell and taste change. Usually, substances which prevent oxidation, antioxidants, are added to food containing oil and fat. Keeping food in airtight containers helps to slow down oxidation. Do you know that chip manufacturers usually flush bags of chips with air such as gas to prevent nitrogen chips from getting oxidized?
Hi guys, I'm Nandana of class 10C here to present you about the topic metal. A metal is an element which readily forms positive ions and has metallic bonds. The modern definition of metal is that they have overlapping bands and valence bands in their electronic structure. These are some things which we come across in our daily life, which is made up of some metals. Gold has been used to make some ornamental objects and jewellery. Gold is a soft yellow metal with the highest ductility and malleability. This is a kitchen utensil which is made up of steel. Stainless steel, which is highly resistant to corrosion. It's commonly used in kitchen vessels and cookware. It's also used for hospital equipment. The physical properties of steel include high strength, low weight, durability, ductility and corrosive resistance. This is an iron nail which is made up of iron. Iron is also used to make machinery, tools as well as vehicles, structural elements, buildings, bridges and aircrafts. Iron is a shiny, bright white metal that is soft, malleable, ductile and strong. Its surface is usually discolored by corrosion since it combines readily with oxygen of the air in the presence of moisture. In absolutely dry air, it does not rust. This is an rod which is made up of aluminium. Aluminium is the world's most abundant metal and is the third most common element. The physical properties of aluminium are lustrous, good conductors of heat and electricity, high melting point, high density, malleable, ductile, usually solid at room temperature. This is an electric wire which is made up of copper. Copper is a chemical element with the symbol Cu. It is soft, malleable and ductile metal with very high thermal and electrical conductivity. A freshly exposed surface of pure copper has a pinkish orange color.
The wonders of combining baking soda and vinegar. With all products which made our life easier, there are hidden ingredients in our daily life. Baking soda and vinegar are used for making soaps, shampoos, laundries and so on. Now let us observe the reaction of combining these two components.
Material required: vinegar, baking soda. Take a glass. Pour some vinegar into it. Then add baking soda. And now you can see the reaction. Now let us look what happens when we mix vinegar and baking soda. When vinegar and baking soda are mixed together, hydrogen ions in the vinegar react with the sodium and bicarbonate ions in the baking soda. The result of this initial reaction is two new chemicals, carbonic acid and sodium acetate. NaHCO3 plus CH3COOH gives CH3COONa plus H2O plus CO2. What type of reaction is involved when vinegar and baking soda? Decomposition reaction and double displacement reaction.
The baking soda and vinegar reaction is actually two separate reactions. The first reaction is acid-base reaction. The second reaction is a decomposition reaction. The carbonic acid formed as a result of first reaction immediately begins to decompose into water and carbon dioxide gas. Just like carbon dioxide bubbles in a carbonated drink, the carbon dioxide rises to the top of the mixture. This creates the bubble and foam that you see when you mix baking soda and vinegar.
Hi everyone, I am Aditya. I am going to explain you about elements in our protein. As we all are familiar with elements, we should also need to know about elements in our body. There are 6 important elements in our body. Which are they? Let's take a look. Almost 96% of the mass of the human body is made up of 6 elements: oxygen, carbon, hydrogen, nitrogen, calcium and phosphorus. Only about 0.85% is composed of another 5 elements: potassium, sulfur, sodium, chlorine and magnesium. All 11 are necessary for life. The remaining elements are trace elements, of which more than a dozen are thought on the basis of good evidence to be necessary for life. All of the mass of the trace elements put together do not add up to the body mass of magnesium, the least common of the 11 non-trace elements. Now let us discuss about the function of 6 important elements in our body. Oxygen. The element oxygen acts as an electron acceptor and oxidizing agent. It is found in all 4 of the major classes of organic molecules: protein, carbohydrates, lipids and nucleic acids. Because it is a key element in aerobic cellular respiration, large amounts of oxygen are found in the lungs and in the bloodstream. Hydrogen. Hydrogen is the first element of the periodic table. The most important function of hydrogen in the human body is to keep you hydrated. Nitrogen. It is used to make amino acids in our body, which in turn make proteins. It is also needed to make nucleic acids, which form DNA. Carbon. Every single organic molecule in your body contains carbon. The element bonds to itself to form chains and ring structures that serve as the basis for all metabolic reactions in the body. Calcium. Calcium is one of the most important minerals for the human body. It helps to form and maintain healthy teeth and bones. Phosphorus. The main function of phosphorus is in the formation of bones and teeth. It plays an important role in how the body uses carbohydrates and fats. It is also needed for the body to make protein for the growth, maintenance and repair of cells and tissues. In conclusion, without the elements, a body could not function. Our bodies are the elements. Thank you.
I am Vandana Vijay of class 10. I am going to say about hard water and soft water. We all know that water is the universal solvent. It is a chemical substance which is transparent, colorless, odorless and tasteless. Water is categorized into 2 types, that is hard water and soft water. They are not categorized based upon their feel, touch or appearance. Instead, it is categorized on the basis of mineral content of each. Hard water. Water with naturally present minerals like magnesium and calcium is called hard water. These minerals are beneficial for the health. These minerals add flavor to the hard water. Next is soft water. It is the treated water. It is left only with cations and that is sodium. It has a salty taste. This is soft water and this is hard water. Now we can look what are the difference between these two. Hard water is rich in minerals, but soft water is less rich in minerals. Hard water is not effective in soap, but soft water is effective in soap. That more foam is formed in the soft water than the hard water. The hardness of hard water is due to the presence of magnesium and calcium ion in it. But in soft water, it contains only sodium ion. Hard water makes the skin and hair dry. Soft water makes the skin and hair soft. We can remove the hardness of the hard water by adding washing soda in it. Thank you.
I'm Anjali of class 10B. I'm planning to do an experiment on the topic dissolving and evaporation of salt in water. Here is some water and salt. Add salt into the water and stir it well. Keep on adding salt. You can see that salt is getting dissolved into it. Now I think it reached saturation point, that is why salt is not getting mixed into the water. Now we are going to boil the water to regain the salt. Now you can see bubbles are coming, that means water is getting evaporated. Look at the white color inside wall. It is salt, it's regaining. Finally boiling is done. Water got evaporated and we got our salt back. This is a chemistry experiment which happens in our daily life but we never notice. Thank you.
Hi, I am Arjun of class 10th B, here to present a small discussion on the topic ice floats on water. Why does ice floats? Whenever you put a small ice cube in a glass of water, do you wonder why it floats rather than sinking? We can define this in two ways. First of all, we need to know about density of a substance. The density of a substance is what in which the substance will float or sink. If the substance has less density, then it will float. If the substance has more density, it will sink. So, automatically we think that the ice has more density, so it will sink. But that's not the real fact. The real fact is that ice is 9% less denser than that of water, so it will float. The second explanation is that when the liquid is cooled, more molecules are brought together under a smaller area. This results in more density. But it does not happen with ice. Ice has a positively charged hydrogen atom and a negatively charged oxygen atom. When the water cools, the hydrogen atom adjusts with the oxygen atom to prevent the sinking.
As we all know, air is a mixture of gases and contain moisture. The gases and water present in the air react with the surface of metals and form their oxides, sulfides, carbonates or sulfates. The formation of these compounds eat up metal slowly. This phenomenon is called corrosion of metals. Silver articles becomes black after some days when exposed to air and the black coating formed is called silver sulfide. Copper reacts with carbon dioxide and moisture in the air and slowly loses its shiny brown surface and gains a green coat. This green substance is called copper carbonate. Iron, when exposed to moisture and air for a long time, acquire a coating of brown flaky substance called rust, and corrosion of iron is known as rusting. The main disadvantages of corrosion of metal are loss of metal from the surface, change in the physical appearance of a metal, change in the chemical properties of a metal, loss of the efficiency of metallic machines, a decrease in the lifespan of metallic objects. There are many ways to prevent metals from corrosion. Some of them are painting, galvanization, electroplating, alloying, anodizing, and cathodic protection. Paints can protect metal from the degrading effect of environmental gases. Galvanization is the process of applying a protective zinc coating to steel or iron to prevent rusting. The most common method is hot dip galvanization, in which parts are submerged in a bath of molten zinc. Electroplating is the process of coating a metal with a thin layer of another metal by electrolysis to improve the metal's corrosion resistance. Alloying is a process in which two or more metal elements are melted together in a precise combination to form a specific material or alloy.
Anodizing is an electrochemical process that converts the metal surface into a decorative, durable, corrosion-resistant anodic oxide finish. Anodizing is accomplished by immersing the aluminum into an acid electrolyte bath and passing an electric current through the medium. Cathodic production is the method of preventing corrosion on submerged and underground metallic structures. Cathodic production is one of the most effective methods for preventing corrosion on a metal surface.
Exothermic reaction. The reaction in which heat is evolved is known as exothermic reaction. The best example for this is burning of natural gas. The equation for the burning of natural gas is CH4 plus O2 gives CO2 plus H2O plus heat.
Baking soda. Sodium hydrogen carbonate, commonly known as baking soda or bicarbonate of soda, is a chemical compound with the formula NaHCO3. It is a salt composed of a sodium cation and a bicarbonate anion. Here are some of the properties of baking soda. As it has long been known and is widely used, the salt has many related names such as baking soda, bread soda, cooking soda, and bicarbonate of soda. In 1791, French chemist Nicolas Leblanc produced sodium carbonate, also known as soda ash. In 1846, two American bakers, John Dwight and Austin Church, established the first factory in the United States to produce baking soda from sodium carbonate and carbon dioxide. There are many uses of baking soda. Let us look some of them. In cooking, baking soda is primarily used in baking as a leavening agent. When it reacts with acid, carbon dioxide is released, which causes expansion of the batter and forms the characteristic texture and grain in cakes, quick breads, soda bread, and other baked and fried foods. Mild disinfectant. It has weak disinfectant properties and it may be an effective fungicide against some organisms. Because baking soda will absorb musty smells, it has become a reliable method for used booksellers when making books less malodorous. Fungicide and pest control. Sodium bicarbonate can be an effective way of controlling fungal growth and in the United States is registered by the Environmental Protection Agency as a biopesticide. Alkalinity and pH increase. Sodium bicarbonate can be also added to swimming pools, spas, and garden ponds to raise the total alkalinity. Fire extinguisher. Sodium bicarbonate can be used to extinguish small grease for electrical fires by being thrown over the fire, as heating of sodium carbonate releases carbon dioxide. However, it should not be applied to fires in deep fryers. The sudden release of gas may cause the grease to splatter. Personal hygiene. Toothpaste containing sodium bicarbonate has in several studies been shown to have a better whitening and plaque removal effect than toothpaste without it. Sodium bicarbonate is also used as an ingredient in some mouthwashes. It has anti-caries and abrasive properties. It works as a mechanical cleanser of the teeth and gums, neutralizes the production of acid in mouth, and also acts as an antiseptic to help prevent infections. Cleaning agent. Sodium bicarbonate is used in a process for removing paint and corrosion called soda blasting. Medical uses and health. Sodium bicarbonate mixed with water can be used as an antacid to treat acid indigestion and heartburn. Its reaction with stomach acid produces salt, water, and carbon dioxide. A mixture of sodium bicarbonate and polyethylene glycol such as Peglite dissolved in water and taken orally is an effective gastrointestinal lavage preparation and also laxative prior to gastrointestinal surgery, gastroscopy, etc.
I am Pavitra. I am going to explain a few things about acid rain. Acid rain or acid deposition is a broad term which includes any form of precipitation with acidic components such as sulfuric or nitric acid that fall to the ground from atmosphere in wet or dry forms. This can also include rain, fog, snow, and dust, and even dust that is acidic.
Acid rain is caused by a chemical reaction that brings components like sulfur dioxide and nitrogen oxide are released into the air. Acid rain usually has a pH between 4.2 and 4.4. Acid rain causes health problems in people, harms forests, damages buildings, lakes, streams, objects. A great way to reduce acid rain is to produce energy without using fossil fuels. Instead, people can use renewable energy sources like solar and wind energy. Renewable energy sources can help to reduce acid rain because they produce much less pollution. Thank you.
Hi everyone, I am Lakshma. I am going to explain the reactions of quicklime with water and some of the uses of its product form. Do you know what happens when quicklime reacts with water? Calcium oxide or quicklime reacts vigorously with water to produce slated lime or calcium hydroxide, releasing a large amount of heat in the process.
In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide.
Such a reaction in which a single product formed from two or more reactants is known as a combination reaction. Now, can you guess why our skin burns when brought in contact with quicklime? As mentioned before, the reaction of quicklime with water is highly exothermic and produces a lot of heat. Therefore, if we touch quicklime with wet hands, it reacts with the moisture on our skin and the heat generated leads to the burning of skin.
Finally, do you know what are the uses of slated lime that is produced from the reaction of quicklime and water? One main use of calcium hydroxide or slated lime is the whitewashing of walls and roofs. During the process, lime is dissolved in water and the slated lime solution formed is applied on the walls and roofs. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. Calcium hydroxide is also used in the production of bleaching powder when subjected to the action of chlorine in the purification of sugar and in the manufacture of dye stuff.
Hope you have understood how quicklime reacts with water to produce slated lime, how their reaction leads to the burning of skin when we touch quicklime with wet hands, and some of the uses of slated lime, which is formed as a product of their reaction. Thank you.
Hi everyone, I am Neha Farin of 10th A of Vasavi Vidyalaya, here with a PowerPoint presentation of non-metals. Diamond, carbon, phosphorus, sulfur, oxygen, chlorine, nitrogen, graphite, potassium, hydrogen, iodide, bromine, etc. are some of the examples of non-metals. Now we can see the properties of non-metals. They are dull, brittle, do not react with acid or copper chloride, do not conduct electricity, low boiling point, low melting point, usually found as a gas. Now we can see what is a non-metal. A chemical element such as boron, carbon or nitrogen that lacks metal properties and is capable of forming anions, acid oxides, acids and stable hydrogen compounds. Now we can see the uses of non-metals. First one is oxygen is used for breathing. Chlorine is used for purifying water. Phosphorus is used in crackers. Non-metals like nitrogen is used in fertilizers. Graphite is used as a good conductor of electricity. Potassium is used in fertilizers. Nitrogen is used by plants. Now we can discuss briefly about oxygen, which is a non-metal. Oxygen is element number 8 on the periodic table of elements. Molecular oxygen or oxygen gas has the formula O2 and is therefore diatomic, has 2 atoms. It can exist as a liquid at extremely low temperatures. Oxygen makes up about 21% of the gas in the atmosphere. Now we can see about hydrogen. Hydrogen is a chemical element with the symbol H and atomic number 1, with a standard atomic weight of 1.008. Hydrogen is the lightest element in the periodic table. Hydrogen is the most abundant chemical substance in the universe, constituting roughly 75% of all baryonic mass. Now we can see about iodide. Iodide is a chemical element with the symbol I and atomic number 53. The heaviest of the stable halogens. It exists as a lustrous purple-black non-metallic solid at standard conditions that melts to form a deep violet liquid at 114 degrees Celsius and boils to a violet gas at 184 degrees Celsius. Now we can see the uses of iodine. Iodine is important in medicine in both radioactive and non-radioactive forms. Iodide and thyroxine, which contains iodine, are used inside the body. A solution containing potassium iodide K1 and iodine in alcohol is used to disinfect external wounds. Iodine is sometimes added to table salt to prevent thyroid disease. Now we can see about carbon. Organic chemistry is often defined as the chemistry of carbon, but this definition would include calcium carbonate, that is CaCO3, and graphite, which more closely resemble inorganic compounds, non-metallic chemical elements with the atomic number 6 that readily forms compounds with many other elements and is a constituent of organic compounds in all non-living tissues. Now we can see about bromine. Bromine is a chemical element with the symbol Br and atomic number 35. It is the third lightest halogen and is a fuming red-brown liquid at room temperature and evaporates readily to form a similarly colored gas. Its properties are thus intermediate between those of chlorine and iodine. Bromine found in everyday household products as well as in food. That is, bromine is used in boiled water, bread, certain asthma inhalers, toothpaste, mouthwash, hot tub cleaners, pesticides, vegetable oils, flame retardants, cosmetics, etc.
Hi everyone, I'm Tanya of class 10 and I am here to explain you about the science behind ant bite. Ants are social insects that we see on our home, fields, etc. Most of us may have experienced an ant bite in our life. When an ant bites or stings, we may feel pain or a burning sensation. This is due to the formic acid, otherwise called methanoic acid, which gets injected on us when an ant bites or stings. The pain due to the ant bites can be treated with baking soda or alkali. This is because the venom of ant is acidic in nature. So by treating it with base such as baking soda and alkali helps to neutralize the effect of ant bite and produces neutral salt.
Good morning everyone. I would like to speak about bleaching powder and its uses. Bleaching powder is a pale yellowish powder existing with strong smell of chlorine. It is soluble in water, but due to presence of impurities, we never observe a clear solution. Chlorine gas is used for manufacturing of bleaching powder. Bleaching powder is produced by the action of chlorine on rice flake. Its chemical formula is CaOCl2. Uses of bleaching powder. Bleaching powder is used for bleaching clothes in textile industries. It is used as an oxidizing agent in many chemical industries. It is also used for disinfecting drinking water to make it germ-free. Thank you.
Colloidal solution. Colloidal solutions or colloidal suspensions are nothing but a mixture in which the substances are regularly suspended in a fluid.
A colloid is a very tiny and small material that is spread out uniformly all through another substance. Due to the relatively smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture, for example, milk. Because of the small size of colloidal particles, we cannot see them with naked eyes, but these particles can easily scatter a beam of visible light. Tingel effect. Most common example for a colloidal solution. The scattering of a beam light is called the Tingel effect after the name of the scientist who discovered this effect. Tingel effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Tingel effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist contains tiny droplets of water which act as particles of colloid dispersed in air. Properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed, that is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal particles. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Colloids are classified according to the state, solid, liquid or gas, of the dispersing medium and the dispersed phase. Examples of colloids in daily life. There is a huge number of products that we get to use either directly or indirectly on a daily basis. Some of these products are quite relevant to our life. Rest are although used in some way or other, but we never get to see them in our immediate surroundings. The examples of colloids that we usually find around us are as follows. Liquid aerosol. The various types of insecticide spray or repellents we use against mosquitoes and other insects. Smoke or the smoke and fog combination which creates a thick, slowly moving colloidal material. Naturally occurring fog and clouds. Solid aerosol. The naturally occurring smoke or man-made fire smoke carries suspended particles in the air, dust storm or simply dust in the atmosphere. Foam. The shaving cream lather used for shaving purpose. The whipped cream we get to see in cream batter. Emulsion. Various types of cosmetic lotion we use on a daily basis. Mayonnaise we use as bread spread. Naturally occurring milk. Gels. The butter that we usually use as bread spread. Jelly products that we use as various spreads. Salts, man-made paints, ink and other products which are basically combination made at a high temperature.
Do you know how plants prepare food? Yes, it is by photosynthesis. What is photosynthesis? It is related to chemistry, the process in green plants and certain other organisms by which carbohydrates are synthesized from carbon dioxide and water using light as energy source. Photosynthesis is usually represented as 6CO2 plus 6H2O gives C6H12O6 plus 6O2. When light falls on chlorophyll, energy present in photons is absorbed by the chlorophyll molecule. This energy pushes an electron in chlorophyll molecule to a higher energy level. This electron from chlorophyll is transferred to an electron acceptor. As a result, chlorophyll gets oxidized by losing an electron. The acceptor gets reduced by the accepting the electron from chlorophyll. Thus, the energy present in the photon of the sun light is used to eject an electron from chlorophyll. This is the basic mechanism by which solar energy is trapped by chlorophyll.